Hi, my name is Bailey Call, and I am an interpretive naturalist at Silverwood Park. And today I'm going to talk to you a little bit about microplastics, what we can do to avoid these microplastics from getting into our natural ecosystems, and steps we can take to improve the quality of those ecosystems.
All right, so I just kind of wanted to go over some basic information about microplastics. So microplastics are pieces of plastic that are about 5 millimeters or smaller, so very small pieces. And these are some just common types of microplastics, and we'll go over them here so you can get to more familiar with some of these products. So the first one that most people think about are fragments. So fragments are small pieces of plastic from a larger plastic object. So these might be different colors or shapes or sizes because of the way that larger plastic item had broken down. Okay. There are also nurdles. Now, nurdles are plastic pellets. These pellets are usually used in manufacturing, and they are melted down to create specific products. Another type are fibers. A lot of fibers are synthetic or made of plastic, and this is the most common type of microplastic. And these are from strands of clothing, so this is just dryer lint, but they're very, very hard to see because they are so small. There is also foam. So this is kind of a manufacturing foam. So this is something you might see in a stuffed animal or in a quilt. And these pieces of foam are often found in our waterways. And this foam can also be pieces of a food container or coffee cups that have broken down into smaller pieces. So that is foam. And then finally, I wanted to go over microbeads. So microbeads are usually used in soaps and cosmetics. And in a lot of places, they are actually outlawed. But if you can see these, they're very small. They're usually placed as an exfoliant in many products. And so these are tiny, tiny pieces of plastic that can enter our ecosystems. There are also a lot of manufacturers that are working on creating a more natural form of microbeads. So these are just some types. There are other types of plastic as well, but these are just a couple of types of different microplastic. So we are going to actually move into a game that I want to test your knowledge about what we just learned about microplastics and see if you can figure out what we're looking at is a microplastic or not. All right, let's see if we can figure out which one of these are microplastic. So A, B, C, D, E, or F, put your votes in. All right, let's talk about each one. So A is craft glitter. Is that a microplastic? This is manufactured as a microplastic, though there are some natural glitters being produced. This is traditional glitter, so it is a microplastic. All right, B, are craft beads a microplastic? Technically, no. They are not a microplastic yet. Once these break down into smaller pieces, this would be what we would call fragments. These beads are not a microplastic because of their size. All right, C, wool. Is wool a microplastic? Wool is not a microplastic. It is a natural fiber made from sheep. This is not considered a microplastic, though there are a lot of synthetic fibers being made. All right, D, this is foam. This is a microplastic. Yep, and this is one of the most common ones in most waterways. D is a microplastic. All right, E, this is dryer lint. This is considered a microplastic because of the amount of synthetic fibers in this dryer lint. That is a major problem. It's one of our smallest microplastics. All right. And finally, F. Is F a microplastic? Looks like beads. These are actually glass beads, so they are not a microplastic. They are not made of plastic at all. I hope you enjoyed playing this game with me and got to learn a little bit more about microplastics. Something that I want to kind of talk about is ways that we can prevent these microplastics from ending up in our ecosystems. These microplastics can be seen in the guts of a lot of animals because they ingest them, because they don't realize that they look different than their prey items. So, for example, these are what would maybe look like to a predator some fish eggs, but in fact, they are incense. These are some smelly incense that you would put in your bathroom or maybe in your kitchen, but these are in fact made of plastic. And so these can end up in waterways, and they can actually confuse quite a bit of our wildlife into eating them. So something to think about is how these plastics might affect the wildlife around us. So we're going to go into more detail on how we prevent some of these plastics from making it into our ecosystems.
All right, so we've gotten to see what types of microplastics exist and some of the impact that these microplastics have on the ecosystem. But I wanted to talk a little bit about solutions. So we'll talk quite a bit about collective action, and then we'll talk about some of the testing and the experiments that are happening right now on microplastics. So the first thing that we're going to touch base on is collective action. And collective action is defined as the action taken by a group of individuals to achieve a common aim in overcoming a social dilemma. And so this is that physical action that's being taken. Now, there's also the collective action problem. So this is the conflict between individual interests and the group interests. So things like the normal actions of many people using plastic causing environmental degradation. So this would be the problem piece of that. So as we move through this presentation, a couple of things I just want you to think about is given the enormity of this plastic problem, what do small scale things like cleanups do? And when I say cleanups, I mean going out and removing other people's litter or trash from an ecosystem. What does that do as far as an environmental impact? The other thing I want you to think about as we move through this is how can we move from cleaning up, just acting in the act of cleaning up these pollutants, to eliminating the need to actually clean them up. So steps we can do to reduce our microplastic use and what that looks like. Okay, so really the first thing I want to think about when we talk about collective action is the scale. So what does it look like from a small scale, medium scale, large scale cleanup? So these are some groups around the world who regularly do cleanups. These are groups that have taken action in their local communities to work on cleaning up those communities, to removing some of these pollutants. So cleanups can look like a lot of different things, but what we find most often is that there are local cleanups. So for example, this gentleman here who cleaned up 1,500 pounds of garbage from Lake Hiawatha, to regional cleanups, larger areas such as the Dock the River program or some of these larger scale cleanups that happen throughout our communities, and then how those feed into international cleanups. So cleanups that clean up an entire area of shoreline, or cleanups that build into these larger group initiatives. So the scale really does compound. It goes from that local to the regional to those international cleanups, which can have huge impact. Each one of those steps is important to making sure that our ecosystem can thrive. So when we talk about collective action, I don't want to just talk about cleanups, because that is great collective action. You're removing those pollutants from the environment. But there are other collective action steps that you can take in promoting environmental stewardship. So conservation, managing, monitoring, education, advocacy. And we'll go into each one of these in a little bit more detail and provide an example of what these look like. And because collective action can look a lot of different ways. So we'll start with conservation. Conservation is protecting, maintaining, or restoring a natural area. So this would fall, our cleanups would fall under this category. This is basically organizing people to make impact on a certain environmental area, or protecting a certain environmental area from the introduction of pollutants. So in this photo, this individual was walking in their local area, and they saw this beach shore and decided that they wanted to do something about it, and made this huge impact in cleaning up the trash from this shoreline after it had washed on shore. So simple areas like that, and gathering people together so that you make a larger impact can be really beneficial. So conservation is one form of collective action. Another one is managing. So managing an area for the use and managing it for the ecosystem health. So for example, partnering with schools and businesses in your area and creating a vast amount of information where people know how to treat that area, or creating guidelines for its use. So this is an example here, the Fourth Estuary. And these people banded together, and there's actually a forum for how the ecosystem is doing, and kind of guidelines on how to operate within this community. So that's kind of a cool project. And then there's also monitoring, so indicators of ecosystem health or other stewardship outcomes. So collecting information and data, what kind of pollutants are being collected in a certain area? How much is being gathered from like a weight standpoint? How much trash, how many pollutants are actually being gathered together in a certain area? So you can see this map over here is actually a map indicating these shorelines and the amount of pollutants that have been collected from those shorelines. And this type of monitoring can really help change and provide information to understanding what is actually happening in an ecosystem. So that's another form of collective action. Another one is education. So educating about the environment and environmental issues, talking about the impacts of pollutants, talking about the impacts of plastics on an ecosystem or animal, or some of the watersheds. So this group of students actually went out to look at the watershed, and while they were there, talked about microplastics in their environment. So kind of putting that information out there, getting it available to people so they really know what's happening with some of these plastics. So another way is advocacy. So advocacy can look like basically advocating for environmental policy at any level in the public arena. So that might look like meeting with policymakers or submitting petitions or reports. One example of this is this group right here, Clean Ocean Action, actually posts statuses of legislation related to plastic pollutants, and how people can support those legislations. So advocacy can look like a lot of different things as well. So collective action is really a multifaceted kind of approach to this huge environmental impact. We can make so much more headway if we're working together in combating this issue. We can really make a big, significant change. And it might look like advocacy, it might look like conservation, it like monitoring. It can look a lot of different ways, and we have so many good resources out there for thinking about how to not only take those collective actions, but reduce our use and reduce our personal plastic usage. So there's a lot of really great resources like this that are available, but collective action has a huge impact. One other thing I wanted to mention was this brand new research that has just come out. So this young man you see pictured here actually is a young scientist, and he developed a way using ferrofluids, which is small bits of iron suspended in oil, that ferrofluid, and putting it into solution or into water with magnets to remove microplastics. And his experiment was actually 87% effective after 1,000 tests, which is pretty good. And I'll show you more about those steps as we move forward here. So basically what happens is there's a small sample containing microplastics. The ferrofluid and oil are added to that solution, and it's agitated or shooken up. And then another vial with magnets is added, and the magnets actually pick up the ferrofluid and the microplastics in producing kind of clearer liquid. So I thought it'd be kind of fun to try this experiment. So we have all the things that we need to do that. So we're going to move into this experiment next. Let's do that now.
All right, so for this experiment, you can see I have a beaker that I've filled with just some tap water. I also have a vial with some earth magnets inside of it, and it's actually inside of its own test tube. I am going to be using foam for this experiment, which we saw earlier. It's these small pellets of plastic, and finally ferrofluid. So that is this, but you'll see me putting it into the beaker with a pipette. So our first step is to add our microplastics. So I am going to just get some of our foam, just a small amount, and I just added it right there so you can see it kind of floating on the surface right now. I am going to, using a pipette, grab a little bit of our ferrofluid and very carefully not stain anything. You can see it being added here, and it's sinking. It's very heavy. You can see I'm adding quite a bit of ferrofluid into our experiment, and then I am just going to agitate it by stirring with my pipette here, and it does stain pretty easily. So you can see the top that does not have water in it is pretty stained. And then finally, I am then going to apply my magnet with my test tube into the ferrofluid, and we'll see what happens. So here we go. You can see it's starting to collect all of that ferrofluid at the bottom. Probably used too much, but what I want to show you is actually that if you can see that, all of that foam that we had on the outside has now gotten stuck to the test tube. Pretty effective. We'll go in one more time and wipe this off, and then see if we can't collect a little bit more. Here we go. And you can see the top rim is where the ferrofluid normally would have been agitated. But you can see that even on my second go around here, we are collecting quite a bit of those microplastics via that magnet. So a pretty cool experiment, a really neat way to show what is being done in the scientific community to try and learn more about these microplastics and trying to combat some of them. So I hope you really enjoyed that experiment. kind of a neat one. You can see that water on the bottom is quite clear. All right, so how do you know if what you're buying or what you own contains a microplastic? So they're likely not going to just say microplastic on the ingredients list, but there are some ingredients you can look for, and those are kind of broken down by two categories. There are these red flag ingredients, which are considered to be microplastics, and then there are these orange flag ingredients, which need additional research to confirm whether or not these are microplastics. So you can see sometimes they contain more than one. So here's an ingredient list with all of the microplastics underlined in red. A great way to avoid microplastics or buying microplastics is to repair what you already have. A big one is microfibers that are synthetic or are microplastics. And these fibers are very tiny. They get into waterways through our washing machines. For example, these socks right here are actually almost all polyester, which means that they are mostly microplastics or microfibers. You can also purchase things that are made out of natural fibers, such as wool. So if you can see that, that is actually a natural fiber. So that breaks down over time versus the synthetic fiber. But a great way to avoid a lot of this is to just be able to mend some of the things that you already have. Repairing what you have can really help reduce the amount of new microplastics that are entered into our ecosystems. So it's something to think about when you are making these choices about things to buy versus things to repair or fix or mend. So it's just something to keep in mind as you're shopping, as you're looking at things around your home, something to reference when you're buying something new.
Thank you so much for joining me today, and I hope you learned a lot about microplastics and the ways that we can combat this global issue. I hope that we can take action together and make a big change for our natural ecosystems.